Alright, this video is intended to help you complete your Ixl V.9. So I went through and I found a couple examples of different problems. Alright, so the first kind that you may see, or a variation of them, let's say we have 3 to the 6th times 3 to the 5th. So we notice that we're multiplying and also that our bases are the same number. So if we're multiplying, our bases are the same, this is when we are going to add our exponents. Okay, so here this would simply equal 3, and then we add the 6 plus 5, so it would be 3 to the 11th. Okay, another example could be, let's say we have 3 to the 4th times 2 to the 4th. Now recognize your bases are not the same, but your exponents are. So this is when, I should put this here, bases are same. All right, here our bases are different, but our exponents are the same. Okay, so here we would just multiply our bases, keep the exponent. So multiply the bases, and then keep the exponent. So we would do 3 times 2, which is 6, keep the power of 4. So that would be our answer, 6 to the 4th. Okay, so now let's look at some division. So here, for division, let's say we have the same bases. So let's say 10 to the 35th divided by 10 to the 5th. All right, in this situation, we're dividing, same base, so this is when we would want to subtract exponents. And this is bases are the same. Okay, so we would have 10, and then 35 minus 5 would give us 30, so 10 to the 30th would be our answer. Okay, now another example. Now let's have our bases be different. So let's say we have 9 to the negative 2 divided by 3 to the negative 2. Okay, so the same thing applies here. I'm not going to rewrite it, but our bases are different. Our exponents are the same. So then this is where we would actually just divide our bases. Well, 9 divided by 3 is 3. Keep the same exponent. Okay, so those are some examples you may see. Another example, let me just go back here in purple. Let's say we had 5 to the 16th divided by 5. Bases are the same. You must subtract exponents. We need to remember, though, when there's not an exponent there, that's a 1. So this would equal 5 to the 15th, because you would have to do 16 minus 1. So remember that if there's nothing there. All right, another thing is we're going to need to know we may have our power to power rule. So let's say we have 5 to the 2nd power inside parentheses with a 3 on the outside. So power to power, this is when we would multiply our exponents. So this would be equivalent to 5. 2 times 3 is 6. So that's another rule. Another thing you might see, let me give you a couple more examples here. Let's say we have 12 to the negative 4 over 6 to the negative 4. All right, so notice here our bases are different again, but exponents are the same. So we're actually going to divide 12 divided by 6, which is going to give us 2. We keep that same power of negative 4. But what could be possible is they only show you solutions with positive exponents, because they're also going to make sure you know your negative exponent property. All right, so in this example, to apply the negative exponent property, this is where you would have to move it to the denominator, and then it becomes positive. All right, and over here to the side, I'm actually going to just review the negative exponent property, because you might have to apply it in a few different occasions. So the negative exponent property, and this will be probably the last thing for this Ixl. All right, so let's say we have 2 to the negative 3, and we need to rewrite it as showing with a positive exponent. Currently, we would say, if we had to make this a fraction, it would be over 1. We just don't have to show that. So if I had to say, if I just had the 2 to the negative 3, I would say that's my numerator, And then the 1 that we don't have to show is my denominator. Okay, so in order to show then a positive power, it would have to be moved to the denominator because the negative power was in the numerator. All right, so say I had 5 to the negative 4th. I want to write it as a positive. Well, currently that negative power is in the numerator. It then could go to the denominator, and now it's positive. And these are the same values. All right, or let's say we get an example to where we have a answer, and let's say it is already a negative exponent, but it's now in the denominator. Well, now to make it a positive exponent, you would move it to the numerator. So it just goes to the opposite location. So all of those are equivalent expressions. So you're going to need to know that a little bit for V.9 and also V.10. All right, so hopefully this video will help you get this IXL done. Remember, SMART score 70, and then you could stop.